gentlemen. This is the last afternoon session. And we start with Antonis Papaioannou. He will speak about the topic that you can read on the board. Thank you, please.
Hello, my name is Antonis Papaioannou, and today I'm going to present our position paper, which is about C2C, an automated deployment framework for distributed applications on multi-clouds. This is a joint work with a master student, Flora, Karniavoura, and my supervisor, Kostas Magoutis. We are all with the Institute of Computer Science support here in Crete. Today, most of the applications rely on the increasingly decentralized global infrastructures. Typical distributed applications comprise of multiple software components, and these software components typically operate off one or multiple cloud platforms. So they need to be deployed on different execution environments. On the other hand, application modeling languages try to model the applications in a more abstract way in order to provide portability characteristics. One recent approach about the modeling languages is CAML. CAML stands for Cloud Application Modeling and Execution Language. It's a collection of domain-specific languages that try to cover several aspects of the application modeling, of the application properties. CAML is designed to support deployment of applications on multi-cloud environments. One of the domain-specific languages that comprise the CAML language is CloudML. CloudML focuses on the description of the structure of an application, the properties and the resources offered by cloud providers, and the deployment of the application using these resources. So now the question is, how can we realize the deployment of an application described in CAML to the actual cloud providers, to the actual cloud platforms? Towards this way, we choose to incorporate Ceph. Ceph is the de facto standard in the configuration and management tool. It has a strong community and a public repository, a public crowdsourced repository that contains standard management procedures. So the idea is to use the CAML models, the application described in CAML model, and then use the Ceph mechanism to deploy the actual software components on the cloud platforms. Okay, now I will give a brief description of the main ideas, the main properties of the Ceph framework. Ceph is based on configuration scripts. These scripts are called recipes, and a collection of recipes are grouped together. This group target to specific software components, and this group is called cookbook. Ceph follows the client-server model. This means that there are Ceph nodes that refer to the physical servers or to the virtual machines that will be used for the deployment of the application. And this Ceph node should register to a Ceph server. The Ceph server, in turn, is responsible to manage this Ceph node. This is realized by composing a run list. A run list is a collection of recipes that assign to a specific Ceph server in order to deploy the application. Ceph has a strong community and a public repository, a public crowdsourced repository that contains a wealth of cookbooks and recipes. These recipes and cookbooks are available to everyone that want to use in order to deploy the application. Now, I will give an overview of our proposed C2C tool. It consists of three major modules. The first module is the model parser. It takes as input the CAML model, and it creates two lists. The first list contains the VMs that will be used for the actual deployment of the application, and the second list contains the software components that comprise the application. In addition, the second list is also enriched with information regarding the VMs that will host the software components and the dependencies between the application components. The next module is the VM manager. This module consumes the list containing the virtual machines and is responsible to provision the resources, the virtual machines, across the different cloud providers. We use provider-specific APIs and third-party libraries as well in order to be able to provision resources across different cloud platforms. The third module, the third and final module, is the self-instructor. This is actually a wrapper module for the self mechanism that we will use in C2C. This module is responsible to manage the cookbooks, to identify and fetch the necessary cookbooks that will be used in order to deploy the application, create the run list, and assign this run list to the corresponding self-nodes. It is also responsible to derive the order in which the components of the application should be deployed. Okay, now I will dive into a little bit more details about the basic camel concepts that will be used when we parse the camel model of an application. We have the VM instance that refers to a specific instantiation of a virtual machine provided by a cloud provider. We have the component instance that represents an instance of the application, of an application component, and its corresponding configuration properties. The hosting instance is a relationship between a software component and a VM that will host this component. It is also used in order to express that a software component can host another software component. For example, when we have an application server that will host an application server. Finally, we have the communication instance, which is used in order to express the dependencies among the software components of an application. Now, I will show how we can how we can translate these basic camel concepts to the Ceph concepts that are necessary in order to use the Ceph mechanism to deploy the application. So, the VM instance corresponds to a Ceph node. We can extract information from a component instance in order to identify the necessary cookbook that will be used to deploy a software component. The hosting instance is used in order to construct, to assign the recipes, to create the run list that will be assigned to the Ceph nodes. And finally, the communication instance is used in order to derive the order in which the software components will be deployed. Now, putting all this together into a simple image, we have our C2C framework. We fit the input with the camel model, and once we parse the model with the parser component module, we instruct the VM manager module to provision the resources, the necessary virtual machines across the different cloud platforms. Next, the self-instructor component is responsible to search for the necessary recipes and cookbooks in the public Ceph repository and fetch them, construct the run list for the VM, for the Ceph nodes, and finally assign this run list to the corresponding nodes in order to deploy the real application. So, for this position paper, we have implemented a first prototype of our C2C framework. And we used our tool in order to deploy real-life applications. Now, I will demonstrate our experience when we try to deploy the SPEC Enterprise 2010 application in a multi-cloud scenario. This application is a typical distributed multi-tier application that simulates an online web store. The model of this application consists of three major components. We have the JBoss application server, which in turn serves the business logic of the application packed in an enterprise archive file. And these software components are hosted on a VM on a Microsoft Azure cloud platform. On the other hand, we have a MySQL database server, which is responsible to persist the state of the application. And this database server is hosted on an M3 Medium VM on Amazon EC2 cloud platform. So we have two virtual machines that will be used for the deployment of our application. Now the question is, how can we construct the run list for each node? In the case of the database server, the process is straightforward. We want to deploy just a single component, the database server, so the run list that will be assigned to this node contains the recipe of MySQL. On the other hand, for the server VM, we want to deploy two software components. So we take into account the hosting properties as described in the camera model in order to identify that the deployment of the JBoss application server should precede the deployment of the server of the application. Once we have created the run list for each node, the question is, how can, in which order should we deploy this node? So this time, we take into account the communication instance properties as described in the camera model. And we can identify that we have to deploy the database virtual machine first, and then we have to deploy the server VM. Because there is a dependency between these components, the server should contact the database server. So the database server obviously should be deployed before we can deploy the server. Now, as we can see in the figure, most of the cookbooks are already available in the public repository of server. But there is a missing cookbook that relates to the business logic of our application, that we want to deploy this SpecJ component. So we have to construct it on our own. And then we can contribute our cookbook to the public repository. Now, when we design and when we implement the prototype of our C2C framework, we want it to be as automated as possible. But there are a few challenges towards this way. So the first question is, how can we identify the cookbooks that are necessary for our software components? Our first idea is to use properties in the camera model where we can specify the name of the cookbook. Another approach is to search, based on the name of the component, we can search in the public self-repository and find the appropriate cookbook. But in the case that there is not an exact match, we can use techniques for minimal geographical distance and get the cookbooks that have the best match in relation with the name of the component. And then we can ask for the user to choose the appropriate cookbook. Another approach is to assist the developer, the designer of the model of the application, the camel model, in order to rename the components, the names of the application components, taking into account the names of the cookbooks that are already into the public repository of self. Now, these ideas refer in the case where the cookbooks are already in the public repository. But what about the case? How can we handle the case where the cookbooks does not exist at all? So, obviously, we have to create the missing cookbooks. The first approach is to create manually, but this is a time-consuming process and requires the user to be familiar with the camel language, with the self language that is necessary in order to create cookbooks. And although we have created the missing cookbooks by ourselves, We believe that there can be an automated way that can assist users to create cookbooks, generic cookbooks. For example, if a developer has scripts that can be used in order to deploy the application, we can create generic cookbooks and we can encapsulate these scripts in order to create the cookbooks that can be used by the self-runtime system. Now, these challenges refer to the cookbooks, but we have the recipes. How can we choose the right recipe for the desired task? Once again, as with the cookbook, we can use properties in the camel model where we can specify the names of the cookbooks. If we go one step further, we can use specific keywords for the naming of these recipes that semantically reflect the functionality of these recipes. For example, in a cookbook, there can be recipes with the name install, start, stop, and so on, that reflect the functionality of these cookbooks. But what happens with the cookbooks that are already out there and contain recipes with a different naming scheme? In this case, we can leverage the knowledge and the expertise of chef users in order to create alliances, in order to create mappings between the current names of the recipes and the keywords that I mentioned before. So these were the challenges, and now to conclude my presentation, we introduced our C2C framework, which is an automated way to deploy applications that are described in camel models using the chef mechanism. We discussed the challenges and the ways that we can address them, and finally we demonstrated our experience in using our C2C tool for the deployment of real-life applications on multi-cloud scenarios. Thank you.
Okay, thank you very much. Questions, please? I wait for this one.
Without a call, I'd like to take a hard time to Antonis out. That's the really hard question. How close or all that can be fully automated? As you mentioned that, unless I missed something, in one case the human should be part of the loop. Is there any hope that this becomes fully 100% automated?
Yeah, in the case where we can find the cookbooks and the recipes that are needed for the deployment of our application, which I think it's a common case because the repository of the public repository of chef is very active. It has a wealth of cookbooks and recipes. Then this process is fully automated. In the case where we are missing some cookbooks, we can use the automated way to construct these generic cookbooks, as I described before. But in some cases where this is very complicated to be done automatically, then it is required a human intervention in this process. But I think in general, in most cases, there can be an automated process without involving human intervention.
Are there further questions? If not, we thank you again. I'm not sure who will give the next talk. Next contribution is four authors.
The first author.
You are the first author, so please.